All right, I'm looking down at the bottom of page 824. And what if we were asked to solve this by graphing? First of all, you would probably just move the -3 over here by changing its sign, and you would wind up getting 2x squared minus 2 equals 0. And then you would make it look like a function related to that by just saying y is equal to this. Okay? And then you can do a little math and find that the vertex is 0, 2. And then, like I said, if you find the vertex, then you just do maybe 2 points on either side of the vertex, and you've probably got enough points to make your parabola. And when you graph it, the places where the parabola cross the x-axis are your x-intercepts, or they're otherwise called your zeros, or called your solutions. So this particular parabola has, or quadratic function has, 2 solutions because it crosses the x-axis twice. Now, I'm wondering whether we can set up 2 functions, one function that's equal to 2x squared minus 5, and another function that's equal to just -3, and see if we still get the same 2 solutions. Okay, the solutions in this case are where it's crossing the x-axis, but could we, for instance, go back and use this method that we learned in 13, where we split the equation and made 2 functions out of it and figured out that where they cross is the solution? And the answer is, yeah, we can actually do that. So that's what we're going to do in just a second. All right, so first we're going to go ahead and set it equal. First we'll move it over here. So plus x squared, that's going to give us x squared plus 6x plus 8 equals 0. Remember, what I'm doing is adding x squared to both sides. And then the related function is just y equals x squared plus 6x plus 8. Okay. You can make a table of your values. I'm going to go ahead and practice what we've been doing, and that's to find the axis of symmetry and then the vertex. Okay, -6 over 2 times 1 is -3. So this point, whatever that is going to be our vertex. So -3 is going to give me an axis of symmetry right there. Put -3 in and chug out whatever y value that generates. So -3 times -3 is 9. 9 plus -18, because 6 times -3. 9 plus -18 is -9. And then plus 1 is -1, if I do my math right. Okay, so most of the calculations are over here, although one's kind of cut off. -4 squared plus 6 times -4 plus 8 gives you 0 right here. -5 squared plus 6 times -5 plus 8 gives you 3. Of course, you can do all of this by hand, but it's a little quicker to do it on the calculator. And -2 squared plus 6 times -2 plus 8, 0. And -1 squared plus 6 times -1 plus 8 is 3. All right. -3, -1 is right here. -2, 0. -1, 3. Then we've got -4, 0. And -5, 3. So there's our parabola, and it crosses the x-axis there and there. There are your zeros or x-intercepts or solutions. Okay, but let's see if this still works if we do it that other way. If we take the 6x plus 8 and the -x squared and put those in as 2 separate equations. Okay, so I actually went over to Desmos because it's very hard to see on our graphing calculators. But even if I took the equation the way that we had it and just graphed it, and you have like a straight line with a slope, and then this is the other side of the equal sign, you actually still get the same 2 points of intersection. This one's -2, -4, so the x is -2. And then this one's -4, -16. So even doing it this crazy way, I still get -4 as the x value for one point of intersection, and -2 as the value of for the x value of the other intersection. And this time I wouldn't call them zeros because obviously it's not where they're crossing the x-axis because we did it a little differently. The solutions are where those two different lines cross. Okay, I can show you a third method. So let's go back here and let's say that I just decided to do x squared plus 6x equals -8. Let's say that I did it that way, and I did a function that's x squared plus 6x and a second function that's just -8. So let's see what that does. Okay. So y equals -8 is one of them. And y equals x squared plus 6x. Okay. And again, where do those two lines that I graphed cross? They cross at -2 and -4. Again, I'm not going to call them, quote, zeros this time because they're not crossing the x-axis because we're doing them using the intersection of the two equations that I got from splitting the original equation. But regardless of which method you do it, you still get the same x's, the same solutions. Okay. Okay, so before I go on, I'm just kind of reiterating what I just said here. This happens to be given to you in vertex form, which that's no big deal. If you wanted it, frankly, in standard form, you could just basically do the math. Foil this, x minus 4 times x minus 4, and then multiply all of that times 2, whatever. But anyway, I can take this and set it equal to 0 to find zeros or solutions, or I can move the -2 over to here and get 2 is equal to 2 times x minus 4 squared. Do I still get the same solutions if I'm using these two versus just this? Okay, or I could do this and 0, but the x-axis is already 0. Basically, bottom line is, here they're crossing the x-axis, and so the solutions are zeros. Here, I'm using one part of the equation, and then the parabola is the other part of the equation, and where they intersect, again, it's the same values, it's just this time it's not on the x-axis. Either way is helpful, and depending on what situation you're in, you might want to use this method, you might want to use this method, it just depends. We're about to do a little problem with a squirrel dropping a nut, and this is actually the method that we're going to use. We're going to split the equation into two equations and graph them and figure out where those two are intersecting.